First, let's talk about creating attributes. Before we actually do it in Maya, let's first go over some necessary concepts for creating attributes. If we look at my 2D panel, we have a screenshot of the Add Attribute window. We're going to talk about these settings. First is long name and nice name. What do these two names represent? Let's use an example. If we take a look at our Maya scene, let's use the translate attribute we're most familiar with. We can see the translate X attribute in the channel box. In the channel box, it's displayed like this. Translate with a capital T, then it has a space, then a capital X. But what we need to notice here is many of us actually know that Maya doesn't support spaces in names. Since it's displaying a space, there's only one possibility. This name that's being displayed is not the real name that Maya uses internally. This is exactly the difference between long name and nice name. So in the channel box, this name we see with capital letters and spaces between words. This is just so that it's easier for us as users. When we're using Maya and looking at these attributes, it's displayed this way to be easy to read. This is what we call the nice name. So what is a long name? The long name is how the attribute is actually written in Maya. Let's take a look at how translate X is actually written in Maya. Maya by default uses camel case. It uses capitalization to separate words. So here, translate X. Translate is one word, so it's all lowercase. Then X is capitalized. This is the attribute's actual name in Maya. So if we take another example, let's say we write our own attribute. Let's just call this attribute. This is an attribute. If we look here, there are no spaces between each word. It uses capitalization to separate them. This is how the attribute is actually written in the Maya system. Then, in the channel box, Maya will automatically convert it into a name that's easier for us to read. When it converts it, it will split them up based on the capitalization and join them with spaces. If we saw this attribute in the channel box, it would be written as, this is an attribute. Some of us might also know that while Maya doesn't support spaces, it does support underscores. So in theory, it also supports you using underscores. For example, let's use our attribute example again. If we wrote this is an attribute and connected them all with underscores, the attribute's actual name in the Maya system could also be in this format. And in the channel box, Maya would still automatically write it in an easy to read way, with the first letter of each word capitalized and connected by spaces. However, we don't recommend writing it this way. The reason is that this method of using capitalization to separate words is Maya's default way of writing things. The vast majority of nodes in Maya, their attribute format is this way. So we generally, when we, for example, create attributes, we also generally follow Maya's format. But if you are different from everyone else and you use this underscore method, what we see in the channel box is exactly the same. But in reality, when we do more complex operations later, like controlling things with script, because when we use scripts to control things, we have to use the attribute's actual Maya name. At that point, when we see an attribute name like this in the channel box, what we instinctively assume is written in Maya's default format. So in our script, that's how we'll call it. But as a result, because the attribute format we created is different, our script will give an error. When we go to troubleshoot it later, we might end up spending a lot of time tracking down this kind of problem that we probably wouldn't have thought of at first. So I recommend that when we start creating these attributes, have a good habit and stay as consistent as possible with Maya's format. This can save us a lot of unnecessary trouble later on. Another point to make here is that this long name and nice name are not always identical. We can define the nice name ourselves. For example, the long name is still this is an attribute, but we can write whatever we want for the nice name, because the nice name is just for display. By default, Maya splits each word and connects them with a space. But we can also change it here, for example, just display this is a nice name. That's also possible. We can manually type it in. When we manually type it in, we are overriding Maya's default nice name. We can see in our attribute options, there's an option called override nice name. As long as we check this, we can type the nice name we want to define in the field below. This way, the new name will be displayed in the channel box. Okay, now let's look at the next line. There are 3 words here. keyable, displayable, and hidden. First, let's explain what keyable is. Keyable, simply put, means the attribute can be set keyframes. If you've learned animation, you probably know this. When we do animation in Maya, we are actually setting keyframes for each attribute. The change from one keyframe to another creates the animation. So when our attribute is keyable, it means this attribute can accept keyframes. What's the opposite of keyable? It's non-keyable. If the attribute is non-keyable, it means it cannot be keyframed. So that's the difference between keyable and non-keyable. Next, let's talk about hidden. What is hidden? This is really easy to understand. Hidden means it won't appear in our channel box, and the opposite is being displayed in our channel box. Before we continue, we need to talk about Maya's internal logic. By default in Maya, when the attribute is keyable, meaning it's an attribute that can be keyframed, it will by default always be displayed in the channel box. And when your attribute cannot be keyframed, it will by default not be displayed in the channel box. With this logic in mind, let's look at these three attributes again. When we choose keyable, this actually represents two things. First, it can be keyframed. Second, it will be displayed in our channel box. This is Maya's default logic. Next, let's look at displayable. What's the difference between displayable and keyable? They will be displayed in our channel box. We can tell this from the word display, but it cannot be keyframed. Setting keyframes is not allowed. And finally, let's look at hidden. In this case, hidden means it will not be displayed. It will be hidden from our channel box. And at the same time, setting keyframes is also not allowed. This is the difference between these three attributes. In this case, it's a choose one of three situation. It just depends on which one you want to pick. If we don't choose the right one when we create it, it's okay, because we can always modify it later in Maya. Okay, next let's talk about attribute types. In our attribute types options, Maya provides us with the following few: vector, integer, string, float, boolean, and enum. Let's go through this one by one. We'll start with the easy to understand ones. Let's start with float. What is a float? If we've had any experience with programming, we've definitely seen this word. Simply put, it's a number with a decimal point. For example, 1.5, 2.37, negative 4.75, negative 0.02, even something like 1.00. These all count as float. Like we just said, numbers with decimal points, they all belong to the float type. This is also the most frequently used type, because most of the time, the values we use need to include decimals. Next, let's talk about boolean. What is a boolean? We've actually seen boolean before, the visibility attribute on a transform node. We know it's on and off, but essentially, it's also two numbers. It's actually 1 and 0. On is 1, off is 0. Next, let's talk about integer. This one is also very easy to understand. When we don't have a decimal point, it's an integer. Like 0, 5, 18, negative 20, negative 30. These are all whole numbers integers. Next, let's talk about vector. Vector here, it gives us a handy attribute setup. We often use this type of attribute. For instance, translate we're so familiar with. What we see with translate is translate x, translate y, translate z. But in reality, the translate attribute isn't just three simple attributes. It's actually two levels. At the first level, there's an attribute called translate. And this attribute has three attributes inside it. These three attributes correspond to its x, y, and z. So when we actually operate on this type of attribute, we have two choices. One is we can individually edit one of the attributes inside. For example, setting translate x to 10, set it to 0. The other way is we can edit the translate attribute as a whole to control the values of all three attributes at once. For example, we directly assign a value to translate, making it 10, 20, 30. If we do that, it will directly assign to our translate x is 10, translate y is 20, translate z is 30. And if we have another attribute, for example, I create a custom attribute, we'll just call it test. It will also have three attributes, test x, test y, and test z. So in the future, if we want to connect one attribute to another, we still have two ways of doing it. One way is we can connect each attribute individually. Or what else can we do? Because both of these attributes are vectors, we don't have to do it that way. We can just directly connect these two attributes. And in doing so, the values in their three corresponding attributes can also be passed between each other. Okay, so that's vector. Next is string. This is really just for storing text information. For example, we can write anything here like this is a string. It will then take what we've written, whether it's words or spaces, or even some weird symbols, or even some numbers. It just takes everything we've written and puts it in this input field, and stores it as information in this node. From practical work experience, the string attribute isn't actually used that much. Generally, it's only when we're designing tools later on, especially when building rigging systems, that we sometimes need our nodes to store some corresponding information. Only in those situations will we create a string attribute to store it. When we're building rigging functionality, we don't need to use this attribute. So for now, we don't really need to worry about this type. Finally, let's talk about enum. What is this enum attribute? We've actually seen it before. When we're changing the rotate order, we should remember in our attribute editor, when we clicked on rotate order, a drop-down menu appeared. That drop-down menu had several corresponding options. That format is actually an enum. Enum just means we need to add various options. When we select enum, this enum names field becomes editable, and we can then enter any names we want in here. For example, let's enter apple, orange, banana. This way, we have a drop-down menu where we can choose apple, orange, or banana. But one thing we need to be careful about here is these options we've named. They're just for us, the users, to read more easily and select more easily. In the actual Maya system, it doesn't use these names to operate, because we can change these names at any time. For example, right now it's apple. If I change my mind later, I can change it to, say, Tom at any time. But in Maya, it doesn't stop working just because I changed the display name. It still retains its original functionality. So how does Maya itself calculate it? It actually just assigns an index number to each option. Maya's indexing starts from 0. So the first option is 0, the second option is 1, the third option is 2, and so on. So when we select the first option, what Maya knows is that the value we've input is actually 0, so it will use the 0 option. If we select the second option, it knows the corresponding number is 1. If we select the third option, the number is 2. Finally, let's look at this section. This section has 3 input fields for us to use. These are minimum, maximum, and default. This is actually very easy to understand. This is just to give our value a range. For example, a float number. It can be any number. It could be 0. It could be 9,999. It could be negative 10000. This number can be any number we want. But we can also manually define a range. For example, we want its minimum value to be only negative 20. We don't allow it to go below negative 20. So if we try to enter negative 30, it will still only go to negative 20. This is what we call minimum. If we don't enter any number, it means the minimum is unlimited. We can enter whatever we want. Like negative 1000, negative 100, that's all fine. Corresponding to the minimum is the maximum. So for the maximum, let's say we use 30. This means our maximum value cannot exceed 30. When we enter 9,999, the maximum value is still 30. Similarly, if we don't enter anything, then the maximum is unlimited. And then there's its default value. This is just the default value of this attribute when nothing has been changed. Usually the default is 0. For attributes we've used like translate and rotate, their default is 0. But we've also seen some attributes where the default is not 0. For example, scale. The default value for scale is 1. For example, the visibility attribute, its default value is on, which is also 1. So we can define this ourselves based on the different behavior we want this attribute to have. For example, we want to define it as 10. Then when we create this attribute, its default value will be 10. Or we define it as, say, 20. Then when we create it, this attribute's value will be 20.